The humid tropical air clung to everything at Guadalcanal in August 1942. Lieutenant Tanaka Yoshio pressed his binoculars against his face, his hand steady despite the weight of what he was about to witness. 120 men from his company moved through the tall kunai grass toward the American defensive line stretched thin in the distance, perhaps 300 meters away, held by roughly 40 Marines. The mathematics seemed straightforward, 3-to-1 superiority. It was doctrine, pure and simple. The Imperial Military Academy had drilled these calculations into him since 1932. Close quickly, overwhelm with sheer numbers and courage. That's how it had worked in Manchuria. That's how it had worked in China. That's how it had worked in Malaya. Numbers and steel won battles. The officers had never been wrong before. Then the sound started. It wasn't the familiar rhythm he knew so well, that crack, pause, crack of bolt-action rifles. Each shot required a man to work his action, eject the spent case, chamber a fresh round. Time between shots. Deliberate, controlled. This was different entirely. Utterly different. A sustained roar erupted from the American position, almost like machine gun fire, except it was coming from individual riflemen spread across the line. Tanaka watched through his binoculars as his men began falling, not one at a time, but in clusters. 3 men down, 5 more. A squad leader he'd known for 6 years crumpled mid-stride, his momentum carrying him forward before he collapsed into the grass. The Marines weren't working their bolts between shots. They were simply pulling triggers. Again, 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 8 rounds without pause. Then a smooth, practiced motion to reload. 8 more rounds. The volume of fire was impossible. Tanaka had trained his entire career around a fundamental understanding. Riflemen needed 3 to 5 seconds between aimed shots. That was the mechanical reality of bolt-action weapons. It couldn't be violated, yet these Americans were firing as fast as they could acquire targets. Their rate of fire seemed inhuman. 90 seconds. He timed it reflexively, the way officers learned to gauge the tempo of combat. In those 90 seconds, 47 of his men were down. Dead or dying. It didn't matter tactically which. The attack faltered instantly. Men who had charged machine gun nests in China dove for cover. The survivors began crawling backward through the grass, not rooting, not yet, but no longer advancing. The assault simply stopped, broken against a volume of fire that shouldn't have been possible from so few defenders. Tanaka lowered his binoculars. His hands were shaking now, though he tried to steady them. His company had just been defeated by a force 1/3 its size. They hadn't even reached effective rifle range. That wasn't supposed to happen, not to Imperial Japanese Army infantry. Not with 3-to-1 odds stacked in their favor. That night, by flashlight, he wrote his after-action report. His language remained precise and professional, each word carefully chosen. Enemy equipped with automatic rifles. Each rifleman capable of sustained rapid fire without manual cycling. Request machine gun support for future engagements. He used the word automatic because he had no other frame of reference. Rifles were bolt action. Machine guns were automatic. What he'd witnessed didn't fit into any category his training had prepared him for. But the American weapons, they would eventually teach Japan a hard lesson about what happened when you tried to match numbers against industrial capability. They weren't semi-automatic rifles like those the Americans carried. They were M1 Garands, gas-operated, semi-automatic weapons chambered in .30-06 Springfield, feeding from 8-round en-bloc clips, effective out to 550 yards, weighing 9.5 pounds. But the real difference came down to one number. A trained American rifleman could sustain 40 to 50 rounds per minute for as long as ammunition held out. The Japanese Type 99 Arisaka that Tanaka's men carried was undeniably a fine bolt-action rifle. 7.7mm, 5-round stripper clips, accurate to 500 yards. Exceptionally precise, certainly. But bolt action meant something unavoidable. No matter how skilled the marksman, no matter how quickly his hands worked the bolt, he could manage perhaps 10 to 15 aimed shots per minute. The mechanics of working that bolt took time. You couldn't cheat physics. The math was merciless. One American Marine with an M1 Garand could produce the sustained firepower equivalent of 3 Japanese riflemen with Arisakas. Whenever Americans weren't outnumbered by at least 3-1, the Japanese infantry found themselves facing a firepower advantage that sheer courage simply couldn't overcome. Throughout August and September of 1942, reports like Tanaka's started flowing up through command channels from Guadalcanal and New Guinea. Every account told essentially the same story. The enemy had semi-automatic rifles that poured out sustained fire, leaving heavy casualties before anyone could close for hand-to-hand combat. By October, captured American equipment arrived in Tokyo for examination. 20 M1 Garands in various conditions, corroded by salt and jungle moisture, yet still operational. When Japanese engineers at Yokosuka Naval Arsenal first assessed them, their appraisal was cautiously hopeful. Japan had produced some of the finest engineers in the world. They'd successfully reverse-engineered British Vickers machine guns, German optical systems, and various pistol designs. The M1 Garand was sophisticated, yes, but fundamentally mechanical. Nothing supernatural about it. Gas bled from the barrel drove a piston. That piston turned a bolt. The bolt extracted spent cartridges and chambered fresh rounds. When the 8th round fired, the empty clip ejected with a distinctive ping that American veterans would carry in their memories forever. Testing at Yokosuka confirmed the basic principle worked. The captured M1s actually cycled using Japanese 7.7mm ammunition. The cartridge dimensions weren't identical, but close enough. The gas system cycled properly. The rotating bolt engaged correctly. Firing the American rifle with Japanese rounds succeeded on the test range. By January 1943, initial optimism started transforming into something more troubling. Engineers disassembled multiple rifles, measuring every component with meticulous precision. The tolerances proved extraordinary, machining to .001 inches. Spring metallurgy demanded specific steel alloys that Japan didn't have in adequate supply. Gas port dimensions required accuracy to thousandths of an inch. Any deviation caused the firing cycle to fail. The N-block clip mechanism alone contained 8 separate moving parts. Each demanded exact measurements for reliable function under battlefield conditions. More alarming still were captured American production documents recovered from Guadalcanal. Springfield Armory alone was manufacturing 601 rifles daily. By January 1941, 601 rifles every single day from a single facility. Total American production by war's end would exceed 4 million M1 Garands. Every rifle built to identical specifications, parts completely interchangeable between rifles manufactured in Massachusetts and those produced in Michigan. A soldier could field strip 2 M1s, shuffle the components randomly, and reassemble 2 working weapons. Japan's entire rifle production for 1941, across all models and all arsenals, totaled 162,000 bolt-action Arisakas. Different manufacturing plants maintained different tolerance standards. A bolt from Kokura Arsenal wouldn't reliably fit a receiver from Tokyo Arsenal. Parts weren't truly interchangeable, even within the same model designation. The engineers began grasping the magnitude of what they confronted. They weren't being asked to copy a rifle. They were being asked to replicate an entire industrial ecosystem. Precision forging dies, hardened tool steel, controlled atmosphere heat-treating furnaces, and over a century of accumulated manufacturing expertise stretching back to Eli Whitney's revolutionary development of interchangeable parts in American armories. They were being asked to accomplish decades of industrial advancement in a matter of months. Then came the order in February 1944. Imperial General Headquarters demanded results. Yokosuka Naval Arsenal received the assignment. Designation Type 4 rifle. Mass production target for 1945. Initial order of 250 parts, sets for testing and development. The unspoken understanding among the engineers, never recorded in official documents, was brutal and clear. They'd been ordered to perform industrial miracles with an industrial system already collapsing. American B-29 bombers systematically destroyed supply chains. Steel allocations went toward aircraft carriers and fighter planes. Ammunition quality deteriorated as chemical supplies dwindled. The empire's manufacturing capacity burned faster than it could regenerate, but orders demanded obedience. Japan would build its answer to the M1 Garand, or perish trying. Spring 1944 arrived at Yokosuka with cherry blossoms and deadlines that seemed impossible. The chief engineer, a careful man educated at Tokyo Imperial University in the 1920s, had spent 2 decades watching the military consume resources faster than industry could supply. He spread American technical drawings across his workspace, alongside preliminary sketches for what would become the Type 4 rifle. The real challenge wasn't understanding how the M1 Garand operated. The challenge was building it with materials Japan actually possessed. Design work revealed itself as an endless series of necessary compromises. The engineers made thoughtful adaptations, replaced the American N-block clip with a 10-round internal magazine fed by 2 5-round stripper clips. The same stripper clips Japanese soldiers already understood from their arisakas. Troops knew how to load them. Manufacturing stripper clips demanded far less precision tooling than producing those 8-part N-block mechanisms. Maintain the gas-operated rotating bolt, because that was where the semi-automatic capability originated. Switch to a Japanese tangent rear sight instead of an American aperture sight, because Japan lacked the production capacity for aperture sights at scale. Use a 2-piece wooden stock rather than a single walnut piece, because Japan's hardwood resources were already committed to aircraft propellers and existing rifle production. Laid out on the chief engineer's desk, the concept looked like inspired problem-solving. The Type 4 would actually hold 2 additional rounds compared to the M1. It would employ loading methods soldiers already practiced. It would rely on established supply chains and existing training. The changes appeared sensible, even advantageous in certain respects. But every modification sent ripples through the entire system. The revised magazine altered receiver dimensions, demanding new forging dies. The tangent sight changed the sight picture, and training protocols would differ from American methods. The gas port required recalibration for Japanese ammunition operating at different pressure curves than 30.06 rounds. The 2-piece stock modified harmonic vibrations during firing, subtly affecting accuracy in ways that wouldn't become apparent until actual testing. The invisible challenge was manufacturing precision itself. American M1 production depended on industrial infrastructure Japan couldn't replicate. 50-ton forging presses for receiver blanks. Hardened tool steel for rifling buttons, capable of producing thousands of barrels before deteriorating. Controlled atmosphere furnaces, maintaining exact temperatures for exact durations to achieve proper hardness without brittleness. Most critically, interchangeable parts manufacturing, the legacy of Eli Whitney, refined across 140 years of weapons production. Japan in 1944 operated aging equipment, much purchased from Germany or Britain in the 1920s. Priority steel went to Zero fighters desperately defending against American air superiority and to warships that couldn't leave port without being sunk. Machinists understanding precision tolerances were drafted into infantry units, replacing fallen soldiers. Allied bombing of electrical plants meant factories ran sporadically or at reduced power. Summer brought the first prototypes. 20 Type 4 rifles assembled by hand by master craftsmen who fitted each component individually, filing and adjusting until everything aligned properly. These weren't production weapons, these were concept demonstrations, each essentially custom-built. Testing produced mixed results, revealing fundamental obstacles. Best outcome, 40 rounds fired without jamming. Normal result, jamming after 15 to 20 rounds. Worst case, failure to cycle even once, requiring manual operation like a conventional bolt-action rifle. The problems clustered around predictable failure points. Gas port fouling happened because Japanese powder left heavier carbon residue than American propellant, gradually restricting the gas system until insufficient pressure reached the operating rod. Magazine feed lips bent under spring pressure because available spring steel didn't match American alloy specifications. Extractor failures resulted from inconsistent heat treating. Some extractors deformed under stress, others cracked and broke. Ammunition quality variations created extraction problems when cartridge cases didn't maintain consistent dimensions. An engineer's report from August 1944. later recovered by American occupation forces, contained a sentence that captured the entire undertaking. The American rifle succeeds not through superior design alone, but through superior ammunition, superior metallurgy, and superior quality control at scales we cannot match. The numbers were becoming impossible to ignore. American M1 production, by mid-1944, exceeded 4,000 rifles daily across multiple arsenals at Springfield, Winchester, and International Harvester. Japanese Type 4 production consisted of 250 part sets ordered, with perhaps 100 potentially assembled into functioning weapons. American ammunition featured uniform brass cases, non-corrosive primers, consistent powder charges measured to within half a grain, produced by the hundreds of millions annually. Japanese 7.7mm ammunition faced worsening quality control as chemical supplies for primers grew scarce and waterproofing steps were eliminated to save materials and time. The moment crystallizing everything happened on a test range in late summer. A Yokosuka engineer conducted a direct comparison. One pristine Type 4 rifle, freshly assembled, carefully inspected. One captured M1 Garand, well used and worn, but functional, both firing identical Japanese 7.7mm ammunition from the same production batch. Same temperature, same protocol, same shooter. The M1 Garand cycled 80 rounds without a single malfunction. The Type 4 jammed at round 23 when the extractor failed to remove the spent case. The engineer cleared the jam and continued. Another failure at round 47. Another at 62. Same ammunition in both rifles, same conditions. The only variable was the rifle itself. The engineer filed his report with precise clarity. We have copied the parts, but not the precision. Each American part fits every American receiver. Each of our parts fits only the receiver it was made for. We are building 250 custom rifles, not a production weapon. He understood what his superiors refused to acknowledge. The Type 4 wasn't developing a weapon system. It was exposing the chasm between Japanese industrial capability and the demands of modern mechanized warfare. By autumn, even believers at Yokosuka ran calculations yielding the same conclusion. If Japan somehow perfected the Type 4 design, if every technical hurdle was overcome, if production actually started, the timeline meant perhaps several thousand rifles before war's end. Meanwhile, American factories were adding 4,000 M1 Garands to inventory every single day. The United States manufactured more semi-automatic rifles in a week than Japan could produce in a year. The chief engineer continued working because orders required it and because Japanese professional duty demanded commitment, regardless of prospects. But he'd stopped believing in victory. Now he simply tried to give Japanese soldiers something marginally better than what they had, knowing that better would still be vastly inferior to what they faced. The Type 4 wouldn't alter the war's outcome. At best, it might provide a few soldiers a slightly improved chance of survival in battles Japan was destined to lose. Autumn brought cold rain to Yokosuka and growing realization that even a perfect Type 4 rifle would be defeated by the collapsing system surrounding it. While engineers struggled with gas port dimensions and extractor springs, American industrial capacity reached scales beyond mere competition into an entirely different category. The contrast wasn't subtle. American small arms production for 1944 totaled 2.3 million M1 Garands, 2.8 million M1 carbines, and 1.4 million other weapons, over 6 million firearms in a single year. Japanese small arms production for that same period was disintegrating under systematic bombing, material shortages, and workforce depletion that no engineering skill could overcome. But the rifle itself represented only half the complete weapon system. The other half was ammunition, and by late 1944, Japanese ammunition production was failing in ways making the Type 4's technical problems almost irrelevant. American 30-06 specifications, documented in captured manuals that Yokosuka engineers studied with unmistakable envy, revealed M1 reliability's foundation. Brass cartridge cases precisely drawn to exact dimensions, then stress-relieved to prevent work hardening. Non-corrosive primers sealed against moisture infiltration. Double-base nitrocellulose powder graphite coated to prevent gas system fouling, copper-jacketed bullets held to weight tolerances of plus or minus half a grain. Quality control included random sampling with chamber pressure testing and accuracy verification at 100, 300, and 600 yards. Every round manufactured to identical standards. Every round completely interchangeable. Japanese 7.7mm ammunition by late 1944 existed in an utterly different reality. Brass cases were increasingly replaced with steel because copper supplies were exhausted. Steel cases rusted in tropical humidity within weeks. Waterproofing lacquer applied to primers and case mouths was frequently skipped entirely to conserve materials and save production time. Powder quality varied batch to batch as supply disruptions forced substitutions and formula changes. Bullet weights showed variations up to 5 grains because precision manufacturing demanded time and attention ammunition plants no longer possessed. Quality control had become haphazard as trained inspectors were drafted and replaced with minimally experienced workers simply trying to meet production quotas. Marine intelligence reports after battles noted the ammunition deterioration. Hand grenades failed to detonate because moisture compromised fuse mechanisms. Mortar shells contained visibly cracked propellant charges. Rifle ammunition showed surface corrosion even inside sealed boxes. Stripper clips featured bent feed lips from poor steel quality, making loading difficult or impossible. A captured Japanese supply officer's diary contained an entry summarizing the systemic collapse. We are asked to provide first-rate weapons with third-rate materials. The soldiers deserve better. The Empire cannot provide it. The cruel paradox was that Type 4 modifications made it more dependent on ammunition quality, not less. The M1 Garand succeeded partly through tolerance of variation. Its gas system, while requiring precision manufacturing, featured a gas cylinder plug allowing adjustment to compensate for ammunition pressure differences. American ammunition was so uniform that soldiers rarely needed adjustment, but the capability existed. The design included margin for error because American engineers understood combat weapons needed to function under imperfect conditions. The Type 4 adapted Garand principles but was manufactured without equivalent precision tooling, requiring even more consistent ammunition for reliable function. The modified magazine system was less forgiving of cartridge dimensional variations. The recalibrated gas port had narrower operating parameters. Japan was attempting to build a precision instrument with imprecise tools to be fed by imprecise ammunition, while facing an enemy with practically infinite supplies of both rifles and ammunition manufactured to rigorous standards. A woman named Fujiwara Kaiko understood this reality better than most. Promoted to ammunition quality inspector at a Nagoya plant when skilled men were drafted, she worked 12-hour shifts measuring cartridge cases with calipers, rejecting rounds that would have been accepted in 1941. Except by late 1944, rejecting substandard ammunition meant troops received nothing whatsoever. The choice wasn't between good ammunition and bad ammunition. It was between bad ammunition and no ammunition at all. She approved ammunition shipments knowing full well they were defective. Weak brass casings would fail under pressure. Damp primers would misfire or hang fire. Inconsistent powder charges would create dangerous pressure spikes. Every batch she signed off on was technically compromised, and she knew exactly what would happen when soldiers tried to fire them in combat. Her expertise came from 3 years working at a watch factory before the war, where she'd learned the exacting standards of precision manufacturing and quality control. She could examine a single cartridge and predict with certainty how and when it would fail. Thin brass at the case head meant rupture. Primers seated poorly meant hangfires or complete duds. Variations in cartridge length caused feeding jams in magazine-fed weapons. She documented all these failures in inspection logs that sat gathering dust, unread by anyone who mattered. Everyone knew the problems existed. Nobody had the power to fix them. The entire supply chain for quality brass had been decimated by Allied submarine warfare. Chemical plants that manufactured stable propellant formulations had been flattened by bombing raids. The skilled workers who actually understood ammunition production were either dead in the Philippines or starving in the jungles of New Guinea. By December 1944, the raw numbers told a story that no amount of technical skill could rewrite. The Americans possessed more than 3.5 million M1 Garands in active inventory. Japan's Type 4 rifles, assembled at Yokosuka, numbered fewer than 100 total, and not a single one had been issued to combat troops. American industrial output for 1944 alone exceeded everything Japan had manufactured during the entire war. The United States could absorb catastrophic equipment losses and replace the entire inventory within weeks. Japanese forces were fighting with weapons they couldn't replace, maintained by parts that didn't exist, because the factories producing them had been systematically destroyed. By early 1945, Yokosuka engineers understood a hard truth they couldn't voice. They weren't building a functional weapon system anymore. They were constructing a monument to industrial failure, though no one could say such things openly. The project continued not because success remained possible, but because admitting defeat meant admitting Japan had already lost. Japanese institutional culture rejected honest assessments when those assessments contradicted official policy. Engineers kept submitting reports, kept testing prototypes, kept carefully documenting failures everyone recognized as unfixable. Years later, after the occupation ended and speaking freely carried no penalty, one engineer would finally voice what they'd all understood. We copied the Garand's blueprint, but a rifle isn't merely a design on paper. A rifle is the factories that manufacture it, the metallurgical alloys that form it, the ammunition it feeds on, and the supply networks that sustain it. We copied the drawing, but not the industrial nation behind it. He'd grasped this reality by mid-1944, but voicing it would have been professional suicide. The Type 4's failure was written into the project from day one, not because Japanese engineers lacked ability, but because they lacked everything else. The real gap wasn't knowledge or intelligence. It was a full century of industrial development that couldn't possibly be compressed into 18 months. Regardless of how many engineers worked, how many hours they labored, or how dedicated they remained. Final test results filed in February 1945 showed the Type 4 achieving between 60 and 70% reliability under controlled laboratory conditions, tested with the finest ammunition available. The M1 Garand achieved 99% reliability under actual combat conditions, firing standard-issue ammunition. That 30-point gap represented the difference between an industrial power at absolute peak and an industrial power in terminal collapse. By early 1945, American forces were island-hopping relentlessly toward Japan's home islands, while Imperial General Headquarters issued orders that existed in an entirely different reality from physical fact. Direct command came down that the Type 4 would be ready for mass production by summer to arm the defense of the homeland. Engineers at Yokosuka, who'd spent months methodically documenting why this was impossible, received the order with a shared understanding that requests and orders operated under different rules. Feasibility was irrelevant. The command had been issued. Work would continue. March brought the decisive comprehensive field evaluation. 30 assembled Type 4 rifles, representing the finest examples from months of development, underwent rigorous testing by experienced combat instructors who'd survived brutal campaigns in China and across the Pacific. The test protocol was elementary in concept. Fire 200 rounds through each rifle across 3 days, approximating combat conditions with minimal cleaning between firing sessions. The comparison standard was straightforward. Results revealed what everyone already knew but hadn't formally recorded. M1 Garands experienced 0 to 2 malfunctions per 200 rounds fired. Magazine feed failures were nearly non-existent. Gas system fouling remained minimal. Extractor breakage was essentially unheard of. Overall reliability consistently exceeded 99%. Type 4 rifles showed 15 to 45 malfunctions per 200 rounds. Magazine feed failures happened regularly. Gas system fouling became severe after merely 50 rounds. 3 rifles suffered complete extractor failure, rendering them completely inoperable. Overall reliability ranged between 60 and 70%, and that was under ideal controlled conditions with premium ammunition and expert support. The senior instructor's official verdict was professionally diplomatic yet unambiguous. The rifle was not ready for field deployment. It wasn't close to ready. It was unlikely to become ready within any realistic time frame. Given current industrial circumstances, he refrained from writing what everyone understood plainly. Issuing Type 4 rifles to troops facing M1-equipped Americans would mean sending them into battle armed with weapons more inclined to jam than fire when soldiers needed them most. April brought orders that disregarded test results entirely. Production planning accelerated. Factories were theoretically identified, though none possessed the specialized precision machinery required. Die-casting equipment was requisitioned from sources that no longer existed because American bombing had incinerated them. Training manuals were drafted for a weapon that didn't function reliably. Logistics officers calculated ammunition requirements for rifles that would never reach troops. The entire military-industrial apparatus proceeded as if administrative will could override the laws of physics. Then physics intervened in ways planning couldn't overcome. American B-29 raids intensified throughout April and May against Japanese urban centers. Nagoya, a critical arms production hub, endured sustained firebombing that obliterated entire factory districts. Supply chains for steel, coal, and machine tools that had been stretched to breaking for years finally snapped completely. Civilian food rations were slashed to starvation levels, 1,200 calories daily in cities, less in rural areas. Industrial workers were literally starving while trying to operate machinery. The Imperial Navy, which had sponsored the Type 4 project, essentially ceased existing as a fighting force when the battleship Yamato was sunk on April 7th during a suicide run toward Okinawa. June and July brought the final unraveling. Okinawa fell on June 22nd after 82 days of brutal fighting, demonstrating precisely what M1 armed Marines could accomplish. American forces suffered 20,000 casualties. Japanese forces, military and civilian combined, suffered over 100,000. The firepower differential that young soldiers had witnessed at Guadalcanal 3 years earlier had been refined and amplified into systematic annihilation. Remaining steel stocks were allocated to kamikaze aircraft for homeland defense and coastal fortifications being constructed for the inevitable invasion. The Type 4 production plan was quietly shelved without formal cancellation. Engineers were simply reassigned to emergency weapons programs. Grenades, bamboo spears, anything that could be manufactured with the collapsing industrial base remaining. By August 1945, the contrast had moved beyond stark into absurdity. The United States maintained over 4 million M1 Garands in inventory. Arming troops globally, combat tested across every theater, each rifle manufactured to interchangeable specifications so parts could be swapped between weapons built years apart at different factories. Japan possessed approximately 100 Type 4 rifles assembled and sitting in a Yokosuka arsenal. Never issued to troops, each rifle essentially custom-fitted during assembly, representing hundreds of hours of skilled labor, yet incapable of firing 200 rounds without malfunction. August 15th arrived. Emperor Hirohito's voice emerged through radio speakers across Japan, announcing surrender in formal court language most citizens barely comprehended. At Yokosuka Naval Arsenal, 20 Type 4 rifles occupied a storage room where they'd been placed months earlier. The engineers had understood since mid-1944 that the project was doomed. They'd continued because Japanese professional culture demanded effort regardless of outcome. Orders hadn't been cancelled, so work persisted. Now the emperor's voice made continuation meaningless. One engineer would later recall standing in the arsenal courtyard, listening to that broadcast and experiencing two contradictory emotions simultaneously. Grief for the nation's defeat, for the collapse of everything his generation had been taught about Japan's destiny, and profound relief that he would never send a soldier into battle carrying a Type 4 rifle he knew would jam when that soldier's life depended on it firing. The weapon had been a technical failure, but deploying it to troops would have represented a moral failure. At least the war ended before that happened. American occupation forces arrived in late August and discovered the Type 4 rifles during systematic inspections of Japanese military facilities. 20 rifles were confiscated for technical analysis. An American ordnance officer examined them with the trained eye of someone who understood precision manufacturing. He noted the hand-fitting marks, the file marks on internal components where pieces had been individually adjusted, the inconsistent finish quality. He recognized immediately these weren't production weapons. They were prototypes masquerading as a production line. His 1946 report contained an error that would persist in historical records. He labeled them Type 5 rifles, a misidentification based on incomplete information about Japanese weapons systems. The error mattered little. What counted was his technical conclusion, respectful yet devastating. A crude copy of the M1 Garand manufactured with insufficient precision and intended to fire inadequate ammunition. No evidence of combat use, no evidence of reliable function, represents Japan's attempt to replicate American semi-automatic rifle design without the corresponding industrial infrastructure. The Type 4 project had consumed thousands of engineering hours from specialists who could have been deployed on weapons that might have functioned. It consumed scarce steel and machine tools that could have maintained existing production. Most significantly, it squandered credibility with military leadership who'd been promised a miracle weapon that never materialized. By war's end, the gap was insurmountable. American factories were producing over 4,000 M1 Garands daily. Japanese factories were producing 0 Type 4 rifles monthly and would produce none. The rifle intended to save Japan had become evidence of why Japan lost. Proof that industrial wars are won by industrial capacity, not by engineering cleverness or warrior spirit or any other intangible quality Japanese military culture valued over material reality. The Yokosuka facility fell silent in late August 1945, machinery idle, workers gone or reassigned to reconstruction efforts. When the American Technical Intelligence Team walked through its halls, among them was a Springfield Armory engineer who'd spent 3 years designing production tooling for M1 manufacturing. He understood precision weapons production the way a concert pianist understands music, not just the technical specifications, but the entire culture of craftsmanship and systematic process improvement that enabled consistent quality. He examined the Type 4 rifles with genuine curiosity rather than contempt. They were interesting failures, which meant they were instructive. The design adaptations showed intelligence. The 10-round magazine was arguably superior to the N-block clip for tropical conditions, where moisture made the distinctive ping of an empty clip, ejecting potentially dangerous. The gas system demonstrated sophisticated understanding of operating principles. But the execution revealed everything, hand-fitting marks where components had been filed to mate properly. Inconsistent surface finishes suggesting different skill levels applied to different parts. Tolerance variations visible without precision measuring equipment. His report was professionally generous in the way experts can afford when examining other experts who simply lacked resources. He noted the sophisticated problem-solving, the clever adaptations to Japanese manufacturing constraints, the realistic engineering warnings to leadership that the timeline was impossible. But his conclusion proved definitive. The Japanese engineers were highly skilled and understood the Garand's principles, but they lacked the industrial infrastructure for scaled execution. They'd attempted to skip 50 years of manufacturing evolution. The deeper lesson emerged from comparing not just rifles, but entire systems. The M1 Garand wasn't solely John Garand's genius, though his design was brilliant. It was the cumulative output of 140 years of American interchangeable parts manufacturing, dating to Eli Whitney's musket contracts in 1801. It was Springfield Armory's institutional knowledge producing rifles since 1794, continuous organizational learning across generations of engineers and machinists. It was the American steel industry producing consistent, high-quality alloys at scales measured in millions of tons annually. It was a reliable electrical grid keeping precision machinery running without interruption. It was a deep talent pool of skilled machinists protected from conscription because defense work was classified essential. It was an ammunition industry producing billions of cartridges annually, with quality control making every round functionally identical. Japan had attempted copying the rifle without copying the nation that created it. The Type 4 project assumed design knowledge was the critical factor when actually design knowledge represented perhaps 20% of what made the Garand successful. The other 80% was infrastructure, institutional knowledge, supply chain reliability, quality control culture, and industrial capacity accumulated over more than a century. Yet dignity existed in the attempt itself. Japanese engineers hadn't been foolish or incompetent. They'd been handed an impossible task with diminishing resources and ordered to succeed regardless of material reality. The project files archived by American occupation authorities revealed sophisticated analysis, creative problem-solving under constraints, and repeated warnings to leadership that the timeline was unattainable. The engineers had known by mid-1944 that Japan had lost industrially. They'd continued because professional duty demanded it, and because soldiers deserved their best effort even when insufficient. One post-war engineer interview from 1946 captured the essence perfectly. "We knew by 1944 that Japan had lost the industrial war, but we continued because our soldiers deserved our best effort." The Type 4 failed, but not for lack of trying. There was no shame in that, only acknowledgement of material reality. The war had been decided by steel production, electrical generation capacity, machine tool inventories, and logistics networks. Unglamorous factors, military academies, taught less than tactics and strategy. The numbers made the story undeniable. American steel production in 1944 totaled 81.3 million tons. Japanese steel production that same year reached 5.9 million tons, a ratio of nearly 14 to 1. American electrical generation was 279 billion kilowatt-hours against Japanese generation of 35 billion, a ratio of 8 to 1. American machine tool inventory exceeded 1.5 million units, while Japanese inventory was estimated at 200,000, a ratio exceeding 7 to 1. Precision rifles require precision tools. Precision tools require electricity. Both require steel. The foundation determined what could be constructed upon it. The M1 Garand succeeded because it was the product of an industrial civilization at absolute peak capacity, fully mobilized with resource access spanning a continent and supply chains protected by naval dominance. The Type 4 failed because it was the product of a nation that had exceeded its industrial capacity years earlier, now being systematically dismantled by strategic bombing while fighting across an ocean it no longer controlled. General Patton called the M1 the greatest battle implement ever devised, but that assessment was only half accurate. It was the greatest mass-produced battle implement ever devised. Mass production was the superpower. The rifle was merely its expression. By 1957, when the M1 Garand was finally retired from American military service, over 6 million had been manufactured. Many remained in civilian hands for competitive shooting, still firing flawlessly 80 years after their design, testament to engineering, prioritizing reliability and manufacturing processes, ensuring consistency. Fewer than 25 Type 4 rifles survived in museum collections and private ownership. They were rare, valuable to collectors, historically significant, not because they succeeded, but because they represented ambition without foundation. In 1944, a Japanese infantryman with a Type 99 Arasaka faced an American Marine with an M1 Garand across battlefields from Saipan to Peleliu to Iwo Jima. The Marine possessed 3 times the sustained firepower, backed by unlimited ammunition, manufactured to exacting standards, supplied by industrial capacity that produced weapons faster than combat consumed them. Japan had tried closing that gap by copying the Garand, but the gap wasn't the rifle. The gap was the century of industrial evolution behind it, the unglamorous accumulation of manufacturing knowledge, the systematic refinement of processes, the infrastructure investments that seemed wasteful until war revealed them as essential. You can copy a design on paper in months. You cannot copy the industrial ecosystem, making that design producible in any timeline measured in years. The Type 4 rifle proved that lesson at the cost of resources Japan couldn't afford to waste. The M1 Garand proved it by remaining in service long after the war, reliable as always, doing exactly what it was designed to do because everything behind it had been engineered to make that reliability inevitable.